The next part of the chapter, light reflection and refraction, is refraction. Okay. So there are different types of medium. Some are rarer, some are denser. Okay. So if the particles of the medium are very closely packed, we say that as a denser medium. Okay. So if we have a denser medium and if light is coming from a rarer medium, okay, the light is coming from a rarer medium and it is entering the denser medium. Okay. So what will happen to the ray of light is actually it is supposed to go straight. Okay. But there is an interface between the two media. That is, one is rarer medium, the other is denser medium. So when it is traveling from a rarer to denser, the ray will bend towards the normal. Remember, children, if it is moving from rarer to denser, it will move the refracted ray move towards the normal. And at the next intersection, see, it is moving from a denser medium to rarer medium. So if the ray is traveling from denser to rarer, it bends away from the normal. See, the ray of light will bend away from the normal. Okay. So this is actually the refraction through a glass slab, where two refraction is taking place. One is from rarer to denser and the other is from denser to rarer. So basically, bending of light ray at the interface of two media should be there. For reflection to occur, only one medium is required. So bending of light when it travels from one medium to another. When it travels from one medium to another, we call it as refraction. So why do refraction occur, children? Why do refraction occur? Because light travels with different speed. Light travels with different speed. Light travels with different speed in different media. Light travels with different speed in different media. Okay. Basically, light travels faster in rarer medium and very slow in denser medium. So now we can write the laws of refraction. Incident ray, refracted ray, and the normal all lie on same plane. That means you can see all the rays. Second is sine of angle of incidence to sine of angle of refraction is always a constant. We call it as refractive index. So in refractive index, we need to specify the medium. Okay. So who is causing refraction should be written first. So if I am writing N21, it means it is the refractive index of medium 2 with respect to 1. So the formulas for refractive indices are, if it is N21 with respect to refractive index, you should write N2 by N1. But with respect to velocity, reverse, V1 by V2. And with respect to angle, it is sine of angle of incidence to sine of angle of refraction. Okay. So these are the formulas for refractive index. And in the formula, see, suppose angle of incidence is given as 60 degree and angle of refraction is given as 30 degree. So what will be the refractive index? Refractive index is equal to sine I divided by sine R, which is equal to sine of 60 divided by sine of 30. Okay. So basically, how we will write the sine values for angles? We have the angles 0, 30, 45, 60, and 90. Okay. So if it is sine, how you will write? 0, 1 by 2, 1 by root 2, root 3 by 2, 1. For cos, you need to write the reverse. 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. So what is sine 60, children? Sine 60 is equal to root 3 by 2. Okay. And what is sine 30? Sine 30 is 1 by 2. So 1 by 2. So 2 and 2 will get cancelled. Your answer will be root 3, and root 3 value is 1.71. Okay. If it was root 2, the value is 1.41. So you have to be ready with the values of root 2 and root 3. What is the next method to find the refractive index is refractive index N21 is equal to N2 by N1. So problems based on this is they will give you, for example, refractive index of water with respect to glass. So how you will write water with respect to glass? So it is NW divided by Ng. Then they will give you refractive index of glass with respect to air. So how you will write? Ng divided by Na. So suppose if it is written, if it is given like this is equal to maybe 3 by 4 and this is equal to 3 by 2. Okay. So the question will be, what is the refractive index of water with respect to air? So what is required is NW divided by NA is the question. So first, this will be taken as equation 1 and this is equation 2. In the required equation, we need NW first. So where is NW coming? It is in equation 1. So either you can divide 1 by 2 or you can write 1 into 2. Let's see what will give you NW by NA. So what is the first one, children? If it is 1 by 2, so NW divided by NG. Divided by means into NG by NA. So automatically, see, NG cancels and we are getting the same ratio. So how you will find it? 3 by 4 divided by means into the reverse, 2 by 3. So what will be our answer? It will be 6 by 12, which is 1 by 2. So this is how we solve the numerical with respect to refractive index. Now, one more is there. What is refractive index with respect to velocity is V1 divided by V2. Okay. For this, suppose if they are telling velocity of light in air. What is the velocity of light in air? 3 into 10 power 8. And the refractive index of glass with respect to air is 1.5. What is the velocity in glass? So how we will write? We have the formula NGA as VA by VG. Because if it is velocity, it is reverse. So VA is 3 into 10 power 8 divided by VG, we don't know. And this is 1.5. So what will be VG? VG will be equal to 3 into 10 power 8 divided by 1.5, which is 2 into 10 power 8 meter per second. So this is how we do the refractive indices formula. There are 3 formulas which a grade 10 student should know. If it is N21, first is sin I divided by sin R. Second is with respect to refractive indices, same order. With respect to velocity, reverse order. V1 will come first and V2 second. Then one more is there. Sometimes they will tell you absolute refractive index. Absolute refractive index means, it simply means that the other medium is air. It means other medium is air or vacuum. For example, if they are telling absolute refractive index of glass is 1.5, what does this mean? If they are using the word absolute, it means it is N G with respect to A. So these are the concepts which should be clear for, for the refractive indices problem.